So let's take a look this problem. We have a S graph like this. Okay. So for the first step, we should know the relationship of A and S first because we already know the graph. Okay. So for the first range, that is S from 0 to 10. Okay. For that, we have two coordinates, right? That is 0, 0, and this should be 10, 10. Okay. Actually, from this relationship, we can find out. Okay. M is become 10 minus 0 divided by 10 minus 0, that is become 1. Okay, so y equal to mx plus c, but c now it is passed through the origin, so then it means that c is equal to 0. So for this case, we found out a equal to s. Okay, a equal to s. For the first period. And for the second one, from the graph, okay, it is constant. For this case, A is just equal to 10 meter per second. So according to this, we are working with for each period. Okay. So for the first part, we know that A equal to S. Okay. And we know that when S equal to 0, V is become 0 also. And for this case, because we know that A equal to S for the first range, okay, we working out from this relationship, as we know that VDV equal to ADS, okay, and for the first period, that is S is greater than 0 and less than 10. The relationship of A and S is A equal to S. Substitute A equal to S on the right hand side. Okay, indicate both sides. We have this, and when we consider this term, we obtain that V equal to S. Okay, we also equal to S. And after that, it means that for V equal to S for the first range, it means that we can plot the graph here. We may plot the graph here. Is it a linear graph because the slope is become 1. Okay, and it's has the relationship is become like this. That is V equal to S. But for the second range, okay, that for that from 10 meter to 15 meter, okay, we have the relationship of integration of VDV equal to integration of ADS. And when S equal to 10 meter, okay, when S equal to 10 meter, V equal to 10 meter also according to this equation. And then after that, we integrate both sides. And we can find this relationship. Substitute the limit of integration both sides. We get this. And we can determine for the velocity for the case of V is equal to square root of 20 S minus 100. Okay, and if we would like to find the velocity at any case at S equal to 15 meter, we have V equal to 14.14 meter per second. So now we have 2 points. Actually, we should draw the V and S graph. Okay, now, but for this case, this is for S equal to 15 meter. Okay, so we may plot the AS graph. Okay, that is actually we found that for the second period. The velocity function is here. Okay, when we take the first derivative to this term, we got this term. And we take the first derivative to this equation because of what? Because we would like to know the slope, the graph should be what? Because we have no idea about the function in this term, that is the square root of 0.2s minus 100. Okay, so we would like to plot this graph. Okay, but we do not know exactly the graph of velocity function. It should be what? Okay, so then it is recommend to apply mathematical skill. That is when we take the first derivative to this term, we got this term, right? And from this term, we observe that when s is increasing, so then dv by ds is decreasing. Okay, so according to this, we may predict that the graph in this range should be the curve like this. Okay, that is a slope tend to less than the first one. Okay, and this is for the case, the problem that we already work out on Friday. Sorry, on Wednesday, right? Okay, and that's complete this problem. After we draw the graph and we can determine the velocity and we can create the graph. Okay, that is complete to this problem.